We're going to take a look at our homework from last night, page 664, 1 to 5, specifically two of those questions, number 3 and number 5. Starting with number 3, it says, a 5 centimeter high object is placed in front of a 2 centimeters, that is, in front of a converging mirror. This is good news for us. It's a converging mirror. We circle it even though the focal point is positive. We're not going to make a mistake with the sign of this because by default it's positive. But again, we want to get in the habit of circling converging, diverging, convex, concave, just so that we don't forget when it's really important to identify it, i.e. when we got a negative focal point. We have an image that's magnified negative 4x. That's going to be m. Where does the image form, and what is the focal length of the mirror? In other words, we're looking for di. Where does the image form? The image distance and the focal length of the mirror here. So let's write down some givens here. We're going to say HO is 5.0 centimeters. We're going to say DO is 2.0 centimeters. It's a converging mirror where the magnification is negative 4. Where does the image form? We're looking for DI. And we're looking for the focal length here. Now, it's a converging mirror. They don't really need to tell me this, right? Because we're looking for the focal length. If the focal length works out to be positive, then it's converging. If the focal length works out to be negative, then it's diverging. We can figure out whether it's converging or diverging. But because they do tell me it's converging, okay, it's a nice little check for me. If I calculate the focal length and it works out to be negative, I know I've made a mistake because they told me that I should get a positive answer because it's a converging mirror. So we don't need this information, but it is a nice little check for me if they give it to me. All right, listen, we got two equations. I don't know which one you want to start with. I guess because we're missing F and DI, probably not going to use the mirror equation first because it's got both of those equations in it. Probably going to use the magnification equation first. M is equal to negative DI over DO. I think we'll go with that. M is negative 4. Negative DI over DO is 2.0. We're going to solve for DI here. It works out to be 8.0, I think. Is that right? Positive, isn't it? Yeah. Now, I don't like the way they wrote this question. Negative 4. Technically, our final answer should be what? 1 digit, right? Like technically, the image distance is 8 centimeters, not 8.0 centimeters, but 8 centimeters. What type of image is this? Real or virtual? What is it? Real. And how do you know that? Good, because DI is positive value, right? So we're not asked to determine whether it's real or virtual, but we know that if we were asked, we know that it's real. What else are we asked to find here? The focal length. Now let's go to that other equation, the mirror equation. 1 over F is equal to 1 over DO plus 1 over DI. 1 over F is equal to 1 over 2.0 plus 1 over 8. And this is where we got to use our little calculator trick here. We're going to say for this one, 1 over 2 plus 1 over 8. We're going to flip it over, and we get 1.6, which, again, by rights in this one should be 1 digit, right? Which means it's 2 centimeters. Okay, I'm not sure whether they did that. They did that here, but they didn't round it to 1 digit here, right? They said 2 digits there. Again, by rights, it should be a 1 digit answer for both of them. That makes sense? I'm pretty sure on a test or an exam, you're not going to get a 1 digit answer there. They'll give you a magnification to 2 or 3 significant digits. But the bottom line is, on an exam, they always tell you anyways, round your answer to 3 digits or round your answer to 2 digits or whatever. So you don't need to worry too much about making that mistake on an exam. It is positive, which is consistent with what they told me, that it was a converging mirror. All right, number 5. 5, which I don't know, I thought it was a little bit tricky, actually. I know some of you guys thought it was a little bit tricky, but number 5 says light from a distant planet is incident on a converging mirror. Again, it's converging, which means the focal length is positive. The image of the planet forms on a screen 45 centimeters from the vertex of the mirror. Find the focal length of the mirror in the image characteristics. I had a couple people yesterday through the day ask me, like, is there anything else here? Like, anything else that I have given to me? Just one given? And I'm asked to find the focal length from one given? Well, no, you're not given anything else, but yes, you kind of are if we read between the lines a little bit. Let me write down this equation, the mirror equation here. 1 over f is equal to 1 over do plus 1 over di. Now, we're looking for the focal length, right? We're looking for the focal length. We know the image distance. The image distance is 45 centimeters, and it's produced on a screen, so we know that's a positive value because it's a real image. So we're going to say 1 over do plus 1 over 45 centimeters, right? But we don't know what do is. We don't know what do is, but we do kind of know what do is. We're talking about a distant planet. Is a distant planet 1 centimeter away? No. A distant planet is not 1 centimeter away from the mirror. It is not. Is it 2 centimeters away? No. Is it 10 centimeters away? No. It's much further than that, right? What's 1 over 1? 1. What's 1 over 2? 0.5. What's 1 over 10? 0.1. So 1 over, the bigger the denominator becomes, the smaller the number becomes. What's 1 over 1,000? 0.001, right? And 1,000 centimeters, I mean, the planet is much, much further than 1,000 centimeters away, right? I don't know what do is, but I know it's not 1. I know it's not 5. I know it's not 10. I know it's not 1,000. I know it's really, really big, right? Which means 1 over really, really, really big. 1 over really big is really small, which is effectively, compared to the value of 1 over 45, it's effectively what? 0, right? Does that make sense? So we don't know exactly what it is, but man, you compare it to 1 over 45, it's 0, right? To a reasonable number of significant figures is just 0. So we got 1 over f is equal to 1 over 45. What's the value of f then? 45. Now remember we did our activity with lenses here. What day was it? Monday? We found the focal length of the lens by looking at a far-off object through the lens. We said the further away the object is, the closer to parallel the rays are that go through the lens. If you're looking at a planet, the rays that are going through that mirror or reflecting off of that mirror are going to be parallel to each other, right? Where should they converge? At the focal point. The image should be formed at the focal point. So we can do this mathematically like we just did, or we can just think, oh, okay, looking at something really, really far off, then the rays will converge at the focal point, and therefore, just like we did finding the focal point of our activity on Monday, the image will be formed at the focal point. The focal length will be 45 centimeters. Okay? Now, what about the image characteristics? What about the image characteristics of this? Well, let's try to figure out, let's try to get another number for this here. Focal length is 45 centimeters. The image distance is 45 centimeters. We want to find out whether it's, well, we know it's real right now, right? We know it's a real image right now because it's formed on a screen. Is it bigger, smaller, same size? Let's try this. M is equal to negative di over do. M is equal to negative 45 over something that's really, really big. What's that going to give me for magnification? Yeah, something that's really, really small, right? Something that's really, really, really small. Which is, I mean, almost 0. But the thing is, here, you were comparing this number to this number, and it was 0 in comparison to it. Here, you're not comparing it to anything, right? So it is an actual number, not 0. It's just a really, really, really small number. So that means that the image is going to be much smaller than the object. Now we have this idea that a telescope magnifies things, right? The telescope should produce a bigger image, right? But it doesn't. Think about that. You're looking at a planet through a telescope. When you're looking at a telescope, you see the entire planet. The image cannot possibly be bigger than the planet. Like you can't possibly be looking at in the telescope and see an image that's bigger than the planet. Now, if you look at the planet just with your eyes up in the sky, then it looks to be smaller, right? The image that you see through the telescope is bigger than the image that you see just looking up in the sky, but it's not bigger than the actual object. The image through the telescope is smaller than the actual object. Now, is it right side up or upside down? Well, it doesn't really matter too much when you're looking at a planet, right? Whether it's right side up or upside down, but it would be upside down because the magnification would be not something really, really small. It would be negative, really small, right? So that means that it's going to be inverted. So what do we got? It's got a focal length of 45 centimeters. The characteristics are that it is real. They were almost told that in the question because it's focused on a screen. We know that it's inverted, and we know that it's smaller, much smaller than the actual object is. We good there?